Welcome back to this optional video where we will go over cross multiplication. And then I'll also give you a more difficult problem to help you along. So for cross multiplication, I'm going to take this 12 and multiply it by 5. I'm multiplying across the equal sign. And then I will take this 6 in the denominator and multiply it to the numerator on the other side of the equal sign. So the reason I do this is to get rid of this denominator here of 12 and then to get rid of the denominator of 6. This is really the method of clearing fractions, but you're doing it in one step because there is only one fraction on the left side and one fraction on the right side. So what does this give me? This gives me 12 times 5 equals 6 times x plus 3. Use the entire numerator. On the left I have 60 and on the right I have 6x plus 18. I have to distribute this 6 to both terms. Subtract the 18 from both sides. Gives me 42 equals 6x. Divide by 6 on both sides. X is equal to 7. Now, clearing the fraction. I could choose to multiply by 12 times 6, which is 72. So I could multiply by 72. However, sometimes it's helpful to use the least common denominator because it doesn't give you such big numbers. So when I look for the least common multiple of 12 and 6, it's actually 12. So I'm going to multiply by 12 instead of the 72 so that my numbers aren't really large. So I have 12 times x plus 3 over 12 equals 12 times 5 sixths. So now I'm going to simplify before I actually start distributing. So I have a 12 in the numerator and a 12 in the denominator. 12 divided by 12 is really just 1. So my term over here on the left side is x plus 3 equals, I have my 12 realistically, which is in the numerator because this is over 1, and a 6 in the denominator. I can simplify. 12 divided by 6 is 2, and this is really a 1. 2 times 5 is 10. 1 times 1 is 1. I don't need the 1 in the denominator, so I have 10. Subtract 3, x equals 7. Here, equating the numerator, I need to find a common denominator. My common denominator, the best to use for your common denominator is your least common multiple, so that would be 12. So this first fraction is actually going to stay the same, equals. So to make this denominator 12 and an equivalent expression right here, I'm multiplying by 2 in the denominator, multiply then by 2 in the numerator to give me 10. I can see that my denominators are the same, therefore I can make the numerators equal to each other. And I get x equals 7. These are always going to give you very similar equations here and here, because both of these deal with multiplying by the denominator or finding a common denominator. If you're interested in a really hard problem, keep watching. If not, continue on to your next part of the module. Alrighty. Wow, this looks pretty difficult. Let's take a look at this. First thing I'm going to do is look at my denominators, and I'm going to find my least common multiple here. So to find my least common multiple, I need to know the factors of this. So my factors are n squared times n plus 5. My factor here is n plus 5, and my factor here is n squared. I could write this as n times n, and I could write this as n times n times n plus 5. So I need factors from all three of these denominators. I have n times n times n plus 5. I do not need to include this factor of n plus 5 here because I already have it, n plus 5. I don't need the n times n because I've already written those factors here. So my least common multiple is n squared times n plus 5. Now, I'm going to use that and I'm going to multiply here. I am multiplying every single fraction by n squared times the quantity of n plus 5. So I'm going to multiply here. I'm going to multiply here. And I'm going to multiply to this last fraction, 1 divided by n squared. So n squared times n plus 5 times the fraction of 5 over n cubed plus 5n squared equals n squared times the quantity of n plus 5 times 4 divided by the quantity of n plus 5 plus n squared times n plus 5 times 1 divided by n squared. Now I'm going to start simplifying this out and solving this. This over 1. I have n squared times the quantity n plus 5 in the numerator, and this is actually the same thing in the denominator. So when I divide those, that gives me 1. So here is a 5. I have n squared times the quantity of n plus 5 in the numerator, and in the denominator of n plus 5. So I can divide these out to give me 1. So when I multiply it n squared by 4, this gives me 4n squared. Now I'm going to multiply here. I have the n squared in the numerator, n squared in the denominator. That gives me 1. So here I have plus n plus 5. Because when I multiply by 1, it gives me back the n plus 5. Now I have to solve this quadratic. I'm going to subtract the 5 from both sides to set this equal to 0, leaving me 4n squared plus n. Now to solve this, I'm going to factor out the n, leaving me 4n plus 1. Now I'm going to use a zero product property rule and do 0 equals n and 0 equals 4n plus 1. So my first solution is n equals 0. To solve this, I would subtract 1 by both sides to leave me 4n equals negative 1. Divide by 4 on both sides, n equals negative 1/4. Now, here's the one thing that you have to always be careful of when you have variables in the denominator, because that could potentially give you extraneous solutions. So when I look at n equals 0, if I put in 0 here, this gives me a 0 in the denominator, and you can't have zeros in the denominator. That makes that undefined. So this solution does not work. It's called an extraneous solution, okay? It really isn't a solution at all. Negative 1/4, if I plug that in, it will give me back what I need. I hope these videos have been helpful for you. You will not have problems this difficult. This was an enrichment, but if you would like to ask more, please follow up with your teacher.